Okay. Well, I say we go ahead and get started here. Welcome, everybody, to Code PaLOusa. This is our 10th year, and it's actually my first year to speak, so I'm very excited. I really appreciate being able to be here and speaking. But 10th year for a conference, that's pretty awesome, and that's a huge thanks to Chad Green, who runs the conference and has been in charge of it. I'm not sure how long. I believe the entire time. So big kudos to him. There's so much going on, and switching to a virtual conference, that's a huge undertaking. And in some respects, there's even more work to do, as not as many people do spread that work out. So big kudos to him. As well, huge thanks to our sponsors. Not really sure that there would be a conference if these sponsors hadn't been willing to help. So a big thanks to them, and hopefully you have seen their names throughout the day. And but it is sincerely appreciated to Amazon Alexa, Andromeda Galactic Solutions, Software Guild, and Modus or Modus. I'm not 100% sure how it's pronounced, but all right. So here's what we're going to do. When thinking about how to talk about Azure networking, I thought, well, would it be kind of cool if I was to try to make it into a storyline and provide as much really kind of cool graphics as I can. And so what I'm going to attempt to do in this one, and by the way, this talk is so new, I was still editing a couple of slides just up to this point in time. So you 10 folks in here are the first to get to see this talk. So I will ask at the end for feedback. So if it's like, oh no, it just totally sucked, I need to know that. And if it's like, yeah, it went pretty well, it helped explain, I would like to know that, so I know if I'm on track or need to make a lot of changes. So let's get started with our storyline. Welcome. Our story begins at Castle McStone. The king and queen were discussing the use of a vacant area of their kingdom. In the McStone kingdom is a large stone-walled structure. It has been vacant for some time, and it was decided to turn it into a marketplace for people of the land to come and purchase their items, such as for food and clothing and gardening and farming equipment and such. So an architect was hired to evaluate and look over this structure and to see what would be needed to turn it into a marketplace. And after some time, of analyzing the structure and deciding how big is this current structure, how was the length, the size of the walls, etc., how many doors, things like that. So he went through there and then made the judgment calls of, all right, here's what I think might be best based on some of the needs that were expressed. Here's where we can put the different merchants for them to set up their booths, their tents or whatever, in these different areas. And you notice that suppliers is in the far back, and there's a reason for that. So in no time, the merchants came in, they set up their tents, their booths and tables, and started putting out the products that were there and available to them. And the suppliers as well, they set up, but they don't sell directly to the customers. They sell only to the merchants. So in no time, it was such a great big hit. The customers, which the green dots, they started flooding in, and they really enjoyed it. They loved the convenience of being able to get all of their necessities in one place. They didn't have to travel as much, or at least when they travel, they can go to one place and instead of multiples. And the merchants themselves, they absolutely loved the marketplace as well. Having a singular place to sell their goods, it really helped them sell more in a month than any other time. So they were really, really excited about it as well. And the suppliers, like I mentioned earlier, they're in special tents that are set up because they don't sell directly to the customers. They only sell to the merchants. However, it had been noticed that it didn't take long before customers would try to get around the merchants and would visit the supplier tents. They attempted to get in there and see if they could get something cheaper. So a guard was commissioned to stop that traffic and only allow the people that were merchants to come in and not the customers. As well, unfortunately, as it happens, some of the merchants weren't so nice, and some of the merchants were caught stealing from other merchants. That's not so good. So another guard was hired, and his job was to make sure that the only traffic that was between a merchant to any other merchant was the customers and not the merchants themselves. And as well, the merchants can only get their supplies from the supplier tents. Now, some of these merchants, they sell some really cool things. And well, one of them in particular, he sells killer rabbits, right? Because, you have to have a killer rabbit to help defend your property. And now think Monty Python. Follow with me, will you? So the killer rabbits were great for defending your property. And this merchant happened to be a seller of such rabbits. And as well, he sold a special apparatus for flinging the rabbits into the air, introducing the rabbit Flinginator, specially made by DEI. I really hope you get the reference. And these are just fantastic devices. They help get that rabbit further into the air and help defend, like I said, defend your property of those attackers coming in from all directions. Now, some of the merchants had so much for sale that they had a lot of customers coming in, and it became really disorderly. For some of the merchants, not all of them, but for some of them, a little knight was hired to help form distinct lines, and that way, that if a table was getting overloaded, then the knight would help hold the customers back a little bit, and then once a table was freed up, it allowed the next one coming in, and it would help to kind of sort out the lines of the people and try to provide some order to it. Now, as things happen, I mean, this is human nature, right? We find these people and they try to steal, and so it was noticed that some of the customers were stealing, and they were trying to go out of the marketplace with stuff in their bags that they didn't purchase. And as well, some customers were sneaking in with things that were not allowed in the marketplace. So a special knight was hired to manage this, but was also given special authority. And this special authority allowed the knight, unlike the other knights, this knight was able to look inside the bags of people going in and out, and was able to take a close look, and it helped to make sure that none of the disallowed items were coming in, and as well that the items that were going out actually had a proof of purchase of some sort, to help them out, and it really helped cut down a lot of the stealing. And this was a big hit, right? Everybody enjoyed the marketplace. And as more and more customers were coming in, it made it a little harder to know exactly what merchant you need to go find. So a special person was set up so that as customers were looking for the different items, this person would help them direct them to the right merchant to supply their needs. And as I mentioned, this is getting great, right? Everybody loved this. The merchants loved it. The customers loved it. But another problem came up, and that was there were so many people in there at various times. It was actually not safe. It was overpacked and just so overwhelming in this one area. The other thing they noticed is that some of these customers came from such a far away land that, it's great that they came, but maybe they could help them out. And something that was noticed is that a lot of these people came from an area far away that the McStone family, well, they already own that land. So simply made sense. Let's make another marketplace. So in no time, the second marketplace was created. And so now we have one in McFar and the other McStone family marketplace over in McNear. And people were, it was advertising went out to help let people know of the new location, so that if there was one closer to them, it would help them out. But as it happens, not everybody heard of the new location. Sometimes you still got the customers coming in and from that faraway land, just not even knowing that the new location was even available for them. So a young knight, I'm sorry, not kids, knights in training, we shall call them. They were charged with letting the travelers know of the nearest location. So as they come across travelers that they could tell were going to the marketplace, and they'd say, well, where are you coming from? And go, oh, were you not aware that this other location is closer to you? You don't have nearly as far to get, and you can get most of your items, if not all. So there kind of ends our quick storyline of the McStone family marketplace. But let me ask you this. What did you learn? Did you key on the different things that are about networking? Let's see if you did. See, the marketplace itself, that's our virtual network. And it has a certain size. It's going to, you have a certain size of amount of availability inside there, and each virtual network must have at least one or more subnets. And in here, the different areas for the merchants, those are our subnets. And they were specially designed and sized for the various purposes. And although there's really nothing different from one subnet to another, except for their purpose. And you remember I mentioned those tents for the suppliers? Well, those are virtual machines. And those virtual machines have various certain sizes depending on their purpose. And since in our case, in our quick storyline, the suppliers, they hold a lot of items, but not necessarily customer traffic. So they are sized differently than other virtual machines. And remember, we talked about a guard put in place to help cut down customers from getting in. This is where a network security group comes in. And by using a network security group and the rules, we're able to allow traffic from other virtual machines, but not the customers. And if we take a look at the merchants themselves, those merchants, they also represent virtual machines. They're just different sizes and different purposes. You might think of the supplier tent as a database, where these would be your application servers or web servers and such. And it too used a network security group, because you're going to find times when traffic from one subnet should not just be allowed to go to any other subnet. You want to put in some sort of a security aspect in there. And so this is where the network security group and their rules come in. And like I mentioned earlier, that some of the merchants had so much customers at their booth, and it became kind of disorderly. Well, that night there that was helped to provide some sort of an order, and as the traffic flow was coming in, is to help balance that out between the different tables or different virtual machines, if you will, so that it provided not just that balance, but as well that if one of the virtual machines becomes unhealthy, then the load balancer is not sending that traffic to it, but holding it over to another virtual machine. And maybe even provide you some time for scaling and things like that. And now, have you picked up, though, that the customers themselves, that customer traffic, that's network traffic? Hopefully that was a bit obvious. And so as the different network traffic comes in and out, going around, coming in from the internet or some other source, And bouncing around from the different merchants, those virtual machines, a route table is used to help direct traffic to the various areas. And remember, we talked about the firewall being, this knight that's in charge of looking inside the bags of people coming in and going out. This is where a firewall comes in. Now, there's a big difference between a firewall and a network security group. They have rules. They have the things that they allow and not allow. But the difference here is that a firewall can do packet inspection. That is the checking inside the bags, looking at the contents and seeing, is this really harmful? Is this what it really says it is? And as great as our marketplace was, and we built it into another location, well, there's two items in Azure that you can use to help direct traffic to the different regions. In Azure, there's, you might have a south central region in San Antonio. You might have a north central in I believe north of Chicago, and then or maybe in central US, for example, which is in West Des Moines, Iowa. And well, that's really far away, certainly if you're walking, right? So things like the Azure Front Door and the Azure Traffic Manager are items that can be used to help direct traffic on a regional scale to the nearest region. That way, those travelers, that traffic, network traffic, can have the least amount of latency in there. Now, which one should you use on that? Let's discuss some of the differences here. The end goal is, right, is to get the traffic to the nearest region where it makes sense to be at. But the front door is one of the biggest differences is that it can use paths, and it's more of a layer 7. It's an application layer, and it only works on the HTTP level, but you can use paths to help direct traffic. Meaning, what if I need to go to McStoneMarketplace.com? I made that up. I have no idea if there really is a domain for that. And we say /farming equipment. Well, all right, let's pretend that farming equipment is something that is actually not available in both locations. You could set up with that path and say, all right, well, farming, I know this one is actually closer to you, but it doesn't have that farming equipment available. I'm going to have to redirect your traffic over to the other region. But for everybody else, okay, you could come over here to this region because it sells everything else. So you can use paths for that. And as well, Front Door provides rate limiting capabilities, as well as IP address access control lists. That way, if there's just some of that traffic that you know ahead of time you don't want to deal with, you find that one nasty traveler that you know is a thief, right? And as he's coming across and he's looking for the nearest marketplace to get into, no, you've already been identified. We're not going to help you out, and they get denied. Now, the traffic manager, it uses DNS, but it also uses any protocol, not just HTTP. It can use TCP and UDP. So it's more of a layer 4 type of device. Now, me personally, I like that one better, simply because at a TCP level, you're able to handle things a little quicker, a little faster. That's my personal opinion. Other people may vary. And it really, again, it's one of those consultant type answers. It depends on your scenario. It depends on your purpose and your needs. So, all right. So hopefully this is helpful so far. Please let me know in chat if this is like, no, this is completely not what I was expecting, or this is in the right direction. Now, let's touch again on that virtual network. The virtual network has what's called an address space. Now, and technically the Azure virtual network can have multiples, but we're going to focus on just one for simplicity. And I sized my example to be a /22 so that it allows for 1,024 addresses. And then each subnet, well, unlike the drawing, my subnets in my example are the exact same size. I used a /25 so that each of them have an allowed 100 up to 128 addresses. Now, just a quick note, since it is Microsoft Azure, Azure takes 5 IP addresses per subnet for itself. If you're familiar with networking at all, you know that .0 and .255 are not allowed for use. It is internal use. But Azure goes ahead and grabs 3 more. And for example, the .1 is the subnet gateway address. So I made these 5 addresses, and each 128, and they're taking up that space inside that virtual network up to that 1024 addresses. So let's take a look at IP addressing a little bit, just real quickly. Now, if you deal with networking outside of Azure, you'll see things like there's the subnet mask, and you have binary masking. And so in the corner, you see just a real quick example that it uses the AND a property of subnetting with the binary. I mean, so a 1 plus a 0, well, that's a 0, and it takes a 1 and a 1. You can think of it as this. Imagine a light in a room. There's 2 things it has to have, and the one is power, and the switch has to be on. So you can think of one of those items as being the power and one being the switch. If you have, yes, I got power, but the switch is off, then it's not going to come on. Well, the switch can be on, but there's no power. Well, this light's not going to come on. It takes both power and the switch to be on. Okay, there's our quick example for anding. Now, with Azure, though, and among others, but Microsoft Azure, it uses what's called CIDR. And that's the classless interdomain routing. Now, this is kind of a really big topic in and of itself, so I'm going to try to stay kind of high level just for this. And so what's being shown here is, you know, I created my virtual network with a /22, meaning that I'm using the, and I made a typo on there. I'll have to fix that later. So if you notice that the binary version, the binary representation, you've got the 8 ones, dot 8 ones, dot 8 ones, but then you've got some zeros on there. The ones have to be contiguous and the zeros have to be contiguous. Now, for something that's not using CIDR, you could have ones and ones in some of the other spots. They don't have to be left to right. But with CIDR, it is left to right, period, just is. So what does this mean? So if we look at the binary for our top example, you have not 8, but 10 zeros. And then as we add another, and we flip another switch on, if you will, then immediately we're cut in half, and that goes to 512. We add another 1 there, and now we're at 256. Add another 1, and we're at 128. What this is saying is that, imagine the zeros, they represent the spots for the addressing for the number of hosts, the number of virtual machines. And I say that loosely because a virtual machine can have more than one network card, okay, and network interface. So what we're saying here on the top one by using a /22 is with those 10 zeros, we can have up to 1,024 network interfaces. I don't recommend having a single VM with that many NICs. Don't do that. You'll have a lot of problems. But in fact, I'm not even sure off the top of my head what the max is. But you may have several virtual machines. You might have other hosts that take up an IP address. You may, in case for something I've done, for example, is I'll have a single virtual machine that has 4 network interfaces, each one into different subnets, getting different IP address based on that subnet that it's attached to for different purposes. And in my case, it was a specialized firewall. So what I'm saying here is that the subnets that were created in a /25, you can see the subnet masking that was applied for the 128 allowed host per subnet as that was applied. So basically what I did is I grabbed a number and I said, all right, let's create a subnet. What seems small but reasonable and something to that effect. And I grabbed /25 just for the heck of it. I could have done /26 if I wanted to, but I just did this as an example. Let's see how I applied it. So in my virtual network, I created it with a /22, right? And that gives me 1,024 addresses, which if you look there, it says that I can have an IP. Now, again, there's some rules that say .0 and the beginning of a subnet and the end of a subnet are not allowed for actual hosts. But that aside, let's just look at the basic math of things. So it says that my range can go from 10.0.0.0 all the way through 10.0.3.255. So out of that giant area, which, you know, as you imagine with the stone walls around it, and a virtual machine must have at least one subnet, right? I created 5, and I created one for my suppliers. So I can have up to 128 suppliers if I wanted to. And so you can see the address range is from the 0.0, I'm just looking at the last 2 octets, 0.0 through 0.127. That's where the address range ends. Remember, 0 is a number, so it's 128 possible addresses, but the IDs themselves are going to be .0 up through .127. My next subnet begins right at the very next line. You know, so I have this little border of such, so that as one ends on .127, I can start the next one right at 128, and it goes up to its max for that octet, 255. So when I created my next one of 128 addresses, well, I'm out of space on the 4th octet, so I have to move and increment the number in the 3rd octet, so I'm increasing there. So great. Now for the clothing subnet, I start at 10.0.1.0, going through 10.0.1.127, kind of that lower half, if you will, for that of that range. And now farming comes in and takes the upper half. You can kind of see how they're building on each other. They're contiguous. So this allows me to have different virtual machines in different subnets based on purpose. I don't have to have 5 or 10 subnets in any virtual network. Like I said, you can get away with one. You could have one subnet. Let's call it default, because that's really what you would see in the Azure portal, and it would fill the entire space of that VNet if you wanted to. Well, it's hard to make an example out of that one, so I made 5. Okay, really quick, let me touch base. Let me see it in chat. Please let me know. Do you have questions so far? Is there something that I can address before we move on? Or if am I in the wrong direction? Am I in a good direction? Please let me know. Okay, great, Josh. Thank you. Smooth talking. Okay. Okay, so what we're going to do then is I'm going to stop here, and I'm going to show you some resources in the Azure portal. And like I mentioned earlier, I hope you're kind of building up some questions, because I might even be able to just go ahead and apply them and test them out. And we can jump into some virtual machines and try some different things, go apply a rule and test some things out if you would like. And before I do, I'm going to say a quick thanks to some of the people that helped make some of the graphics. David Neal, who gave our keynote last night. He is one of the creators for some of the graphics here, as well as Vector Pocket and BRGFX. Okay, now let's see, find the best way to do this. I think I can jump there. Let's do this. Okay. So what I've done, and in fact, let me show you some code here, is I used a library called PaLOusa. And using this, I was able to use C# and build out my Azure resources. So I had it build out my resource group, my virtual network. I built a storage account for my boot diagnostics, so that way I can get into each of the VMs, and I'll show you what that looks like. So here I built my virtual network, and I said I want a starting at the 10.0.0.0/22, so I can have 1,024 addresses. And then I came in and created my subnets: suppliers, food, clothing, farming, and garden. And you can kind of see how they build on top of each other. And by the way, if you do get some of the numbers wrong, it will fail on creation, meaning that you cannot overlap. Now, you kind of sort of can have a gap, but what you cannot do is start a subnet by, say, .3. You can't do that. It needs to be on a binary line. And I don't mean like .2 is fine because it's a base 2. It's going to be something that is fitting for the subnet CIDR blocks. And remember, as I mentioned, if you go from a /24 to /25, you're adding a single 1 into another spot. Therefore, your address is in half, your host things. So you can't just do start at something at .1, 2, 3, things like that. Okay, so like I said, I used my code here to build out my different virtual networks, my suppliers, and so then I was like, all right, I want to build my virtual machines, my food vendors, my clothing vendors, etc. And so now I've got this quick method for creating a virtual machine. It creates the network interface first, and I tell it what subnet that I want to be on, because it has to be attached to a subnet. And by the way, although I could do static, these are set for, certainly for this quick example, to just be a dynamically applied IP address. And then I create my virtual machine, and I've just chosen something really small, just a V1MS, and I'm using Linux. And if I was to run this, it would take maybe about 5 to 7 minutes to build the virtual machine, and, well, I'm sorry, the virtual network, the subnets, and all of the virtual machines. It is actually pretty quick to build this things out. And then I also have a load balancer. And it looks like I might have maybe forgot to build the route table. And I tell you what, let's go ahead and I'll kick this off. We're going to build a firewall as well. Now, the firewall in Azure, that's a fun one because it's about $2,000 a month. It's not cheap. But considering that it does packet inspection and applies so many other rules and such, it's pretty neat. Okay, so I've made my change, and let me double check. I'm just going to save. I'll make sure there's no type build errors. Okay, great. Let me do PaLOUsa up. And this is going to look and say, well, out of everything that you've defined, there's things that are already there according to its state that has been storing all along. And it says, okay, well, you want to create a route table, and you need a public IP address for the firewall, and we're going to create a firewall. Yep, that's what I want to do. Let's go ahead and do that. Okay, it's 3:20 Eastern. Let's wait on that for just a moment. Okay, as we're looking in the resource group of the things that are already built out, I have several different items. Let me sort by type, and let's see if that might be a little easier to go over. We're going to skip the disk simply because every virtual machine has an OS disk. All right, let's see if what would be good to start with. I've got my 3 suppliers, 0, 1, and 2. I've got my 2 food vendors, 0 and 1. I tell you what, let's jump in and we'll start at that virtual network, since that's kind of where I started in the storyline. Now, my address space that I've elected is like the /22. And here's my list of subnets that I created. And the firewall itself has to be in its own subnet, and it must be with a very specific name. It must be the Azure Firewall subnet, which means you can only have one per VNet too. Okay, so as you can see that there's so many available IP addresses that are left inside of the subnets. This is because there are virtual machines in there. And when I said that, well, Azure takes 5 for itself per subnet, I'm not going to start at 128 available. It'll start at 123 available. So I can see that I've got some resources taken up inside the different subnets. Now I could add, right now it's the, I believe the basic denial of service protection. You can enable this. I think there's an extra charge for that. I'm not sure off the top of my head what that is. And at the moment, so that's the firewall is already being built. You can see there's an attachment here. And there are DNS servers available, but you can also provide your own custom DNS server if you would like. And if you do, you simply provide what the address is to that. You can also do virtual network peering. So as I mentioned, where I've got the 2 regions built out, what if I needed to have a little secret tunnel that connects the 2, and maybe the suppliers are going through the tunnel and connected there? You could set up a network peering here, a virtual network peering between the 2 locations, between the 2 virtual networks. Okay, let me skip over those. Any questions so far? Else I'm just going to continue. All right, let's take a look at one of the virtual machines that was created. So this is a simple Azure virtual machine. It's running Linux. It's just one virtual CPU with 2 gig of RAM. And we'll jump over to the networking. And you can see that it has a private IP address of 10.0.0.133. Well, that's because of the subnet that it's in. It's not going to start at .0 or .1. It would actually start at 128, except that Azure takes 5, 4 at the beginning and 1 at the end. So this one becomes one of the addresses that is available. Now, you can also tell by this network interface here that it's already applied to a network security group that's actually, well, the network security group is applied to the subnet. You can apply a network security group also to a NIC specifically, a network interface card specifically. All right, so I can dig a little deeper, and here I can see the network security group rules that are applicable right now. Okay. I can jump into the network here, the network interface that is, and I can look at what's called an IP configuration. And this is where I can see that it is using IPv4 versus IPv6. It's in this subnet. Now I can change it, but I believe you have to stop the server first and then bring that on, then switch over to another subnet. And IP forwarding, if I was running like I have before, is a custom virtual machine or a custom firewall running on a virtual machine, then it's going to take some of that network traffic and it's going to come inbound for the purpose of being routed to a new location. That's IP forwarding, where the VM here for the firewall is not necessarily the endpoint. It's there for further navigation. That's IP forwarding. Now, in this case, it's off because this is a food vendor. They're not routing customers. They are a merchant. They are an endpoint in that respect. And I could come in here and change this from dynamic to static if need be. And I could also change to some other address and to see if it's maybe available or already taken. Let me skip that because I don't want to mess with that too much. Okay. So that is one of the food virtual machines. Now, I built out that load balancer, and this load balancer has its private IP address. It's 132. The other food virtual machine was .133. This is .132. Well, if we look at the backend pool of this load balancer, I see that I've got 2 food virtual machines. So this is that balance where there's a lot of customers come in and they were kind of disorderly and they were kind of overwhelming the food vendor in our storyline. Here, this is a network, a load balancer to help balance that out of the traffic between the two. And when I mentioned, oh, great, let's make one. I was supposed to have a health probe all set up already. So let's create a health probe. The health probe says, I'm going to check and see, how about with HTTP? And we're just going to do a quick check. And you could do something like health check. It depends on what you have set up. And what this will do is it will actually go to that endpoint every 5 seconds. That's what the interval is for. And if it receives 2 consecutive failures, then it will deem that virtual machine as inaccessible. And then it will take it out of the available list and send traffic only to the other ones. Now, and in my case, I've only got the 2 virtual machines. You could have many virtual machines in here, okay? So if one comes offline, then the other virtual machines are picking up that load. And let's say I've got my rule here. This is the load balancing. This tells it how to distribute a lot of that load. It says, here's my incoming, here's my IP address that's incoming. We're using TCP for this. We're looking at traffic coming in on port 80. Now, if I did 443 here, this does not mean that it's going to be SSL termination. The Azure Load Balancer does not do SSL termination. What this would say is just simple TCP traffic coming in on this port would go out as if it was coming in on a different port. Okay, so we'll leave that at 80 just for simplification. And let's apply it to our new health probe that we created. And let's skip a lot of these other things. Why are we stuck in updating mode? All right, I'm going to skip that because it's only going to add confusion. Okay, so a little wave of the hand, right? All right, network security groups. This is where we were judging and controlling the traffic that was going to our suppliers and keeping customers out. So I set up a quick example where the merchant traffic, they were allowed to go to the suppliers, which is the supplier subnet, the .128. Or I might have that backwards. I don't know. I haven't been playing with this. So I only set up stuff for live production stuff, right? So it's looking at that traffic and it says it's for anything inbound on port 80 from any of these other subnets, then we will allow it. However, in this quick example, we'll say the food merchants coming in, they are not allowed to come in. Any food merchant is not allowed to come into, this is the supplier subnet. That's what caught my eye. We're just going to say pretend that the traffic from the food vendors cannot go to the suppliers, and maybe because the suppliers don't carry food. That's for them to carry something else. So what, in one way, we're saying that subnet, well, there isn't a database here for it. They handle their business elsewhere. So there's no need for traffic to come from that subnet into this other area. So we also have anything that says 65,000 and above. These are default rules. This is for the inbound security rules. And then you have those in the outbound security rules. And you can also see that this is applied, this network security group is applied to 5 subnets and 0 of the network interfaces. Now it can be, you can set them up to go specifically and associated with a network interface specifically. You might be in a case where you're not really trying to control the traffic of everything of a subnet. maybe you've got some rules that are set for the subnet, but you want extra special rules also applicable to a network interface. You can do that. All right. Now, these are the subnets that we have associated the network security group with. Okay, and looking back here, we can see that the route table was set up and my firewall, my Azure firewall, and I have a public endpoint. All right, so I have the network security groups. I have the inbound rules and the outbound rules. And now let's go ahead and take a look at the route table. And what I might need to do is refresh. We'll see. Nope, there's the route table. Now, what this is saying right here, this there is a default route that says anything to the internet, which is the all zeros /0 means any, and in this case, it's the internet. Then anything bound for that, we're actually going to intercede and force that to a very specific IP address, an internal IP address, which is 10.0.2.132. That happens to be the IP address of the firewall. So what I'm saying is any traffic from these subnets, if they try to go to the internet, they are forced to go through the firewall first. And this allows for, so why would you do this in real life? Maybe you've got a virtual machine, you've got a web server on there, and you wrote most of the code, but not all of it. And some of that code is actually trying to get out to the internet, and you may not be aware of it. I mean, it could be stealing things. We don't know. It could be just sending stats, not really sure. But by forcing all of the traffic to the firewall, then you allowing the opportunity of packet inspection and controlling that. You may even have a rule in the firewall that says you're not allowed to go to google.com. Don't need to. But if you need to go to this other specific address to get drivers, for example, I'm just making things up, you can add that, and basically you have an access control list. You have the things that are permitted and those that are not. You can control that. We'll take a look at that in just a second. Being that I just created the firewall, it actually has no rules, but we can play with that if you'd like, and we'll see what's available. Now, please let me know in chat if there's something specific you have in mind that you'd like to look at. I want to basically give a breadth of jumping around and taking a look at various things and how they are applicable and how they apply to each other. But if you have a specific question or scenario, let me know. We'll play with that. Okay. Now let's do this. I'm going to take we'll take a look at the firewall. And you notice there's our private IP address, 10.0.2.132. This is the address that is used for the route table that says, if you're looking for the internet, it's there and it's only over there. You can't get to the internet any other way. But again, for the route table, that's only to the subnets that it is applied to or associated with. Okay, so with this firewall, let's take a look at the rules. And the NAT rule collection, what this is for, and in fact, let me back up one step. The NAT rule collection, I wish this was a bit more evident, but the inbound traffic. And now imagine in our scenario, our story, that we're talking about the customers coming into the marketplace. That traffic coming into the virtual network, which is coming into, well, in our case, it's not the virtual network. This one is, it's coming into this public IP address right here. And if you actually attempt to hit it, you're not going to get anything because there's nothing routed. But traffic coming in, now this, we can say this is our front door of the marketplace. This is the address for that marketplace. The NAT rule collection helps govern the inbound traffic. The network rule collection and the application rule collection, these are for outbound. This is for customers leaving. They've bought their items and now they're leaving the marketplace, going out that same public IP address. So if things were permitted, for example, we have traffic coming from a virtual machine that says, I need to go and get my Windows updates. That's normal. That's not surprising. And you were to sniff the wire and say, well, where are you coming from? It would have the from as being that public IP address. Now, what's interesting about the network rule collection and the application rule collection is, well, which one is executed first? Because as something is applied, the first rule that is matching is what applies. If that means this rule says, a rule in here says I can get out, but a rule over here says that I can't, the network rule collection are executed first. Those rules, they're evaluated first. Then if they're still passing through, they haven't been allowed or denied, then it comes over to the application rule collection. But there are differences here. We'll discuss that in just a moment. So we can look at an inbound. This is going to be inbound rule here. Let's give it some priority. We'll start at 100, it's the smallest one. And every good first thing has to have a good name of like foo. And we look at the protocols. This is not a layer 7 device. This is a layer 4. So you have your option of TCP and or UDP. And if we look at our source type, we could say the source is an IP address. And remember, this is coming inbound, and it has to be the public IP address here. And let me jump over right quick. I should have done this earlier. Oh, never mind. Let's do this because it's quick enough. Let me put this into my clipboard. Come back to the rules, create a new rule collection. There we go. We'll say inbound. And priority of 100, good name of foo because naming is hard. TCP, UDP, single address here. In the destination. Now, I'll quit jumping around. If I'm coming in, and I believe I have that backwards. Let's do star. Anybody, star, for anybody on the internet coming into this public endpoint that is on either any port, hence the star, or I could say if you're coming in on, say, 443, then you're going to go to some device here. And let's just say .10. It actually doesn't exist, but it's a properly formatted IP address. And we can say you're going to do some natting and network address translation. So you're going to say this rule is allowing traffic to come from anybody to this public endpoint on only 443, or you can do comma-based and add to the list. And you're going to actually be sent over to another endpoint inside the private area. And oh, by the way, you're no longer on port 443. You're actually going to be on port 80. Okay, you can do this. That's an option. That's an inbound rule. With network rule collection, now I'm just about out of time, so I'm going to try and hurry up a little bit. We'll just do a quick example here. This is outbound. Rule 1, no spaces, low priority, actually highest priority. And we're going to allow, so here's what I'm going to try to do. I'm going to try to do it fairly fast. Here we have TCP, UDP, or ICMP. This is ICMP is for ping, okay, which also is a layer 4. And my address type is a specific address. And let's say that I'm going to, I'm just going to pick a random, just some random thing. I don't know where that is. Oh, actually, I'll tell you what we can do. What if we did one of the DNS servers? one of the public internet-based servers. And let's not do that. Let's put it over in the destination. If I'm in the, let's do, say 1.0. Okay, /25, I believe I can get away with that. Yep. And let's say you're only allowed now with ICMP, it doesn't have a port specific, so I'm just going to say any. What this is saying is that anybody in this subnet is allowed to ping out to this destination address. Now, what I could do, this is an IP rule, I could do service tags, which are Azure service tags. So maybe I want to, in this part of the rule, say I'm only allowing things to get to an event hub. And you can add to things like Azure Container Registry. Okay, you can add to there. Each one has to have a name. Now, you can also do FQDNs. Let me delete those just to make it a little easier to read. Now, with the FQDNs, that's fully qualified domain name. This is saying that what are you trying to hit? And I could switch this over and say deny. And I'll just pick it on something, not because I have anything against Google by any means, but I can say you're not allowed to get out to google.com. Okay, let me skip the actual creation of those. And let's jump over to application rule collection. And we'll give it some other name, bar, and let's do 100. Let's look at the differences here. Now I could do FQDN tags, like say I would like to allow, again, this is outbound stuff, getting over to the Windows updates. You notice that there's no destination control except here. What this is saying is that anybody in the, we can do the whole subnet here. Anybody on this subnet is allowed here for Windows updates. Now, if there was a rule here in the network rule collection that said, no, you can't do that, it would actually be applied first. In this case, we'll say, nope, there's not a rule. It's allowing it. So therefore, let's go through our application rule collections and go, yep, there it is. It's allowing it. Great. There we go. If there's not a rule at all, then it's denied. You can't go out. It must be supplied. Now, target FQDNs. Let me delete that one. And let's say just some random good name there. I can say anybody on the entire subnet using HTTPS can get to, as their example, Microsoft.com. What does that mean? Well, what if one of the web servers, for example, it needs to, it's being used and one of the actual users that's remote desktop into that virtual machine, they try to browse. Okay, well, you can get to Microsoft. Well, what if you try to browse to a site that you really should be on? You can add that here and add commas in there, and you can also do wildcard. We can do wild a star dot bad website.com, whatever. Okay, you can disallow things here. I would have to change the rule to deny because this one rule, this is why it's a collection. There are multiple rules in this one collection, but this is a collection of either allow rules or a collection of deny rules. Okay. That was a really fast summary of things, and I have a ton more that I can go through. And this is why it's a kickstart into Azure Networking, not necessarily a good, solid, intense overview of things. So what questions do you have? Because we need to get finished up here. What questions do you have, and how can I help you? And I do appreciate any comments. If it sucked, let me know. If it was great, let me know so that I know if what I need to be working on and tweaking with this. No questions? I'm surprised. There is a lot there. You're welcome to contact me afterwards. On Twitter, I am great. Thank you, Ed. I appreciate that. You can contact me on Twitter. It's Code with a Sean W. There's a W on the end. And you will find me on Twitch now. Yeah, I must have dumbfounded everybody. I don't know about that. I don't know about that. But hopefully it was at least entertaining and somewhat informational. But you're welcome to contact me if you've got any other further questions. Thank you, everybody, for coming. Yeah, Ed, and like I mentioned, this is a kickstart into this. So there's so much here to do and absorb and to play with. So hopefully this was a decent enough overview to kind of see how some working pieces engaged, and kind of that storyline was meant to help it be high level, but to help explain some things and show how a kind of a relationship to how they are in the real world. So thank you, Ed. I appreciate the feedback, and thanks for coming.